Good morning, everyone. I'm Phương Ly Pham. Welcome back to the core food waste management. Today, we will conclude the second module and the first study unit with a lesson of strategy to minimize food waste and optimize resource use. In particular, we will discuss about what to do with the remaining waste after the prevention efforts. We are going to see the food waste hierarchy and food waste minimization practice in food processing. Unlike prevention that stops food waste from being generated in the first place, minimization focused on unavoidable or residual food waste that is created along the food supply chain. By following a structural hierarchy, the remaining waste can be handled in ways that conserve resource, reduce environmental impact, and maximize value recovery. The waste hierarchy was proposed for the first time by Art Lansing in 1975, and then it was adapted to the food system. And here we have the food waste hierarchy, as you can see in the photo on the right. The prevention as such is a top priority. Then, even despite all the effort of prevention, we will always have food waste and residual. So the next level after the prevention is redistribution for human consumption. Suppose the but safe food should be redirected to people through donation or secondary processing. It means that the surplus food can be turned into ingredients from other food products, or they can be donated to the people in need. Since there are many people that are still struggling to put food on the table, this is not only a very nice thing to do, but also a way that can conserve maximum value of food product because the food still remain in human food supply chain. And then, if food is no longer suitable for human consumption but still safe, it can be turned into an animal feed. There are regulations and law to be followed, but in this way we can still conserve the nutritional value of food product. Industrial and biotechnological use is the next level after the use as animal feed. Food byproduct can be turned into value-add ingredient like essential oil or bioactive compound or into bioplastic and biodegradable packaging. The next level is recycling and nutrients recovery. So in this level, the nutrients is no longer used for human consumption, but for the soil. Composting convert organic waste into soil amendment, and anaerobic digestion can produce biogas and nutrients-rich digestate that in turn can be processed and turned into fertilizer. A lower level is energy recovery, in which unavoidable waste can be converted into heat, electricity, or biogas through anaerobic digestion or controlled combustion. The lowest level is disposal. This is the least desired option because landfill or incineration without energy recovery waste dedicated resources and they also cause environmental impacts. So this option should be used only when the other options are not feasible. An effective food waste minimization starts with a good understanding about the composition, characteristic, and variability of food waste. Segregation means physically separating different waste fractions at the point of generation. This action reduces contamination, maintain material quality, and support waste handling. Segregation practice include using dedicated containers and with clear labeling for specific waste category in order to prevent the mixing of food waste. Staff training on correct separation is also important, and placing segregation point near waste generation area can encourage the separation of waste. After the segregation, the characterization is carried out to analyze the physical, chemical, and biological property of waste to identify recovery potential and understand variability. Physical factors include moisture, density, and particle size. Chemical factors include pH, nutrient composition, both macro and micronutrients. Biological factors include microbiome load and biodegradability. Waste audit is a practice that can be done in routine in order to quantify and evaluate waste stream over time to locate loss point and monitor trends, establishing baseline data and guide improvement and valorization choice. Typical waste audit can involve direct measurement or sampling at key stage where waste is generated, mass balance calculation to evaluate the quantity of waste, and recording volume, composition, and frequency to monitor the trends. After the characterization, the byproduct of waste can be subjected to valorization, thus transform secondary output into input for new product, from material for other industry or source of energy and nutrients. For example, you can see in the photo, the orange peel can be turned into candy, essential oil, or jams. The valorization of byproduct always should follow this principle. Understanding material characteristic, maintain quality through proper handling, matching byproduct to suitable technology to maximize the recovery yield, ensuring economic feasibility because valorization is pointless if the cost of production exceeds the value of the new product, and finally ensuring regulatory compliance. Some byproduct valorization pathway include nutrients recovery like protein, carbohydrates, or mineral. Biochemical extraction can be applied to recover the sensitive compound like pigment, antioxidant, or essential oil. Bioprocessing, on the other hand, can turn waste and byproduct into biofuel or biodiesel or even organic acid. The byproduct can be processed and turned into biocompostable or biodegradable material, and finally energy recovered. Optimizing process efficiency can ensure remaining material, so waste or byproduct, are handled in ways that conserve resources, reduce environmental factor, and support circularity through innovation, system redesign, and continuous monitoring. The key principle of optimization include process integration and system thinking. Since the all operations are interconnected, we should evaluate them holistically. Research flow mapping means track water, energy, and material flow to identify inefficiency. Closed loop system design means reuse material internally to reduce the external input and waste. And automation monitoring means use the real-time sensor and control to detect issue and guide data-driven improvement. Some approach process efficiency optimization using advanced separation methods to isolate usable fraction. Heat integration system, as I just mentioned, can be used to reuse thermal energy across processes. Washing or cooling water can be subjected to recirculation and purification to be safely reused within the same processing plant. Smart control systems like sensor or alarm can be used to maintain optimal process parameter. Each stage can apply their own minimization strategy, but the result can even be better if there's collaboration with external partners. There are some key elements of partnership like material quality transparency. Accurate information on volume and characteristics should be shared to ensure suitability and avoid contamination. Clear contractual framework include defined responsibility, standard and schedule, and cost sharing. Traceability and documentation support safety, environmental audit, and compliance. Operational integration like coordinate logistics for timely collection and processing can help guarantee the quality of byproduct or material in general. Finally, mutual value creation. So the benefit within the partner must be shared for long-term success. Some type of collaboration include agricultural partnership for nutrients cycling and soil improvement. For example, the compost that was obtained from the composting of food waste can be given to the farmers so they can be used for the cultivation. Energy and waste management partnership for converting residue into energy or fertilizer. Industrial and technological partnership for high value transformation using advanced processor because the recovery of some sensitive compound, for example antioxidant, requires expertise and specific instrument. Social sector partnership for the redistribution of surplus food. Thank you for joining me in this chapter. I hope you enjoy the lesson. In the next study unit, we would start discussing about the circular economy in food system. See you next time.